4.1b, so we're going to do this lesson again, kind of similar to how we did 4.1a. We're going to go over kind of just the basics, and then when you guys do the assignment, it's stuff you guys really know how to do. What's going to end up happening is very similar, where we have a lot of things that end up being equal. So our last lesson was about perpendicular bisectors that cut a segment in half at a right angle. This lesson is going to be about, there we go, angle bisectors. So an angle bisector, we know that it, just by definition, angle bisector, it cuts an angle in half, right? That's what angle bisector means, cuts an angle in half. What ends up happening because of this is that, here's my angle bisector, if we're looking at that picture, it cuts the angle in half. Now that of course guarantees that it's an angle bisector. But what is actually also guaranteed is that it is equidistant. That word again means equal distances from the sides of the angle. So here are my equal distances. 1, 2, that's the distance to the side of the angle. Like if I was on the angle bisector and had to walk, that'd be the distance. Now the important thing here is that in order for it to be equal distances, we need to have these right angles here, because when we talk about the distance to something, I'm talking about walking straight on, right? I could like walk all the way around, or I could walk at an angle. When we talk about the specific distance to something, it means walking straight on at a right angle. So if you don't have these right angles, we can't say that it's equidistant. So again, we need this to be true and the right angles. If you don't have both of those, then we can't say it's equidistant. So once more in this picture, you're going to have equal distances here and equal angles here, and those right angles in the corner. Let's go ahead. The first part of this is kind of the same as last time. We're going to look at the picture and determine, do we have enough information to conclude that P is on the bisector of angle A? So here's P. Obviously, there is no bisector drawn, but if I were to draw it, it might look something like that, right? But I just haven't drawn it. We want to know if there's enough information. So we need two things. We need this point to be equal distances from both sides of my angle. So here's one distance, here's the other. Are those equal distances? No. So what that means is P would, if I were to draw the angle bisector, P would not lie on it. We do not have, again, what we called equidistant. I do have the right angles, which is good. We do need right angles there to be called equidistant, but the fact that this is 4 and 3, definitely not. Yeah, we need both those things. Let's go ahead and try the next one. Is there enough information on the diagram to conclude that P is on the bisector of angle A? So once again, we need from P equal distances to the sides as well as both right angles. So let's see what we got here. I've got this is equal and that's equal, right? 7 and 7. So far, so good. But I only have one right angle. I need to see that I have both right angles. There needs to be one here as well. I want to double check something here. Am I thinking this right? Does one guarantee the other? No, it wouldn't. Okay. Right. Again, even though this is a right angle right here, which means I'm coming straight on, I have no right angle right here. So nope. Again, what we're missing is that right angle. We need to have both to be considered equidistant. And again, when they're equidistant, that guarantees that P would lie on the angle bisector. Looking at this picture now, is there enough information in the diagram to conclude that C is on the bisector? So here's my bisector, if it is a bisector, right? Well, let's see what we got. Do we have equal distances from my bisector to the sides? Are these equal? Yep, that's good. Do we also have them coming at a right angle on both sides? Yep. That means that, yes, C is on the angle bisector, as well as that, not only are these checked off, right? We got equal distances, we got right angles. Also right here, This is telling us these are equal right away. So just that by itself guarantees we have the angle bisector, right? If I've got these marked congruent, that's the whole definition, the basic definition of angle bisector. If this is true, then yeah, these angles will be the same too. Let's try one more. So once more, in order for us to say, yes, if I were to draw the angle bisector, P would lie on it, we need to have equal distances at right angles. So do we have both of those things? Do we have equal distances at right angles? Well, we've got equal distances, but we do not have the right angles. So nope, P is not on the angle bisector. You're missing the right angles. Once again, if you want to make a note to yourself there, missing right angles. We do have equal distances, but not the right angles. So when you guys go to the assignment, again, we're going to do that in class. The important things is this. So today I learned, remember this is at the end of your notes. There's a section there that says today I learned. We're going to copy this in. So take a second here, turn there in your packet. We've already seen that section. We're going to copy it there. So please copy, a segment is an angle bisector if two things. It does two things. It cuts an angle. What's the definition of bisect? In half, right? If I cut something in half, by definition, that is an angle bisector. But because of that, it's guaranteed that this will also be true. If it does cut an angle in half, it is equidistant from the sides of the angles. Once again, that means two things. Equal segments, right? The 8 and the 8 here. But to be considered equidistant, we need to have the right angles as well. When we measure distances, we measure them straight on. We don't measure at an angle, right? So when we come back in class, we'll try a couple problems, but this is the general basic. Again, we're going to have lots of stuff equal to each other, so hopefully this is pretty simple.